right. Hi, everyone. This is Kerim Baran with SolarAcademy. Today, I am here with Armando Solis and Jimena Martinez from Lightsource BP US Operations. They are in the engineering function of the leading development company. And we're going to talk about what solar industry thought leaders are doing in their strategic approach to drive performance and innovation by leveraging and standardizing data in their operations. As many solar industry players know, there's data all over the development process, starting at the very early stages of development, going into selecting sites, starting construction, building the assets, and then operating the assets. And Lightsource BP as a major developer that's developed north of 10 gigawatts worldwide, managing north of 3 gigawatts of assets just alone here in the US market. They're dealing with a lot of data, obviously, and they're constantly looking to optimize their operations. So, with that, Armando, as the VP of Engineering for US, you guys have started a data initiative or internally or to optimize your use of data. And obviously, you guys are using many different tools and SaaS platforms. So can you tell us a little bit about like before this initiative and after this initiative, like what was the reason you guys started this initiative and with Jimena leading it, like how did things evolve and what were the problems you were facing and what are you guys doing now that is a change versus the olden days and then we'll dive deeper into all the good things you're doing.
Sure. So, I mean, in the industry, I think everybody has a really good understanding of collecting data from an operational facility, everything from meter data, met data that we use to characterize performance. But there's a lot of other data that we have in our projects that we don't necessarily use or leverage. And over the course of these first couple of years of operations here in the US, we've started to see how much more value that useful data can bring us. And we've looked at some, third-party vendors, suppliers, all across the project life cycle. So today we're going to focus a lot more on the operational side, but we do see a lot of value across the entire fleet and where our business starts to where we start the operational portion. So, one of the things that I wanted to help exemplify, especially through the work that Jimena has brought up, is leveraging data to help us optimize, as you just said before, performance and really, make these projects generate more energy. Now, that's not to say, harnessing more power from the sun. It's really being efficient and effective in the operations and the maintenance services that we do. So there's a lot of this data that we can use to leverage personnel time, et cetera, but it all takes effort to put it into one place that makes it usable.
Got it. And with that, you guys, I guess, gave the charge to Jimena to start analyzing looking at all the different buckets of data internally, and then come up with some methods and approaches internally, and to, I guess, standardize and optimize which data to prioritize and how to collect it all and how to make sense of it all.
Yeah.
And with that, Jimena, maybe you can tell us a little bit about this initiative you've been leading internally and some of the insights you've encountered in your efforts to make sense of this data.
Yeah, so we look at very different types of data all the time. We have SCADA data that gives us, meter power, inverter power, met stations, like Armando said. So that gives us insight into the operations of the plant. But we also have data, for an example, is like who is the EOR, who is the mechanical EOR, what type of fuses,
EOR.
engineer of record.
Yep, engineer of record. Yep.
So there's a lot more data that doesn't come from the SCADA that we're trying to capture. And earlier this year, Armando, tasked me with finding a better way to use this data and a better way to capture this data. And that's where Storm came to light. So myself and Juliet and Connor, my two interns for the summer, started thinking about all the different resources that we have for each site. And, you know, in our team, different people that have different inputs into this data and how we would capture it all. So this tool is called Storm. It stands for Site Tool for Optimized Resource Management. And essentially it starts with a form, with an input form that goes to the project engineers. So the project engineers are responsible for building the projects to spec and guiding all the technical discussions around that. So they're the ones who give us what inverter type it is, what module type it is, what tracker, what SCADA system. And like I said, who was the electrical EOR, who was the civil engineer, who was like all these different points that we get even before we have data for the plant. So
Is this collected in even before going live during the construction process?
Yeah, because for example, we get different sets of as-built or drawings for the site. And as-built are at the time of substantial completion. Once the EPC is done, you get the last set of electrical drawings. But then before that, there's the 30%, 60%, 90%. But we always know, early on, what is the equipment on site, what fuses we're going to use. And sometimes that changes. So Storm starts with an input form where they fill out all the information. And then the second layer would be the project manager or the construction manager. And they add, different things that came along the way. And they're the ones who actually have to input the last set of documentations and, verify that we have the weather stations working and that we have the Met layouts and that, they're kind of like supporting roles, but they're two different types of data inputs. And after that, the next person responsible would be the O&M manager. So the O&M manager inputs anywhere from, is there an O&M building? Do we have sheep on site? Do we have video cameras? So there's like different people who are responsible for different data at different times. So what we did at Storm is just collected it all. And we're able to use, the technical data, the admin data, so we know what portfolio the site belongs to. And then we also have the resources. And the resources can be internal or external. It can be anywhere from an electrical as-built, an inverter data sheet, but it can also be a third-party SaaS for like a drone flyover or a SCADA platform or a soiling station platform. I think there's a Fraxen soiling station. So we have links to all of that through a single tool called Storm. And it's Storm because it's a little bit funny because it's a storm of documents that we have to deal with sometimes. So it's really easy to just have them kind of consolidated in a single place. And then the last person who's ultimately in charge of maintaining this data is the asset manager. So yeah, that's Storm.
This is all in the purpose of creating essentially a digital twin of the asset on the ground with full on, almost like a health records for humans, but it would be the health records of a solar asset or a power plant, essentially. Is that a fair way to categorize that?
I'm personally really excited about where the industry is going in terms of having a digital twin. I think we're able to get to that right now with drone technology, surveying the site, and we get, what's called the digital twin, and it essentially is a live map of the site. But as we go on, we're able to feed more information into the digital twin, right? So a digital twin, essentially what it is a digital mock-up of the site that results in a single module has a place and then it has a history. So if that module is replaced, essentially in the digital twin, you can see that that module has been replaced or an inverter fault or all these issues are kind of layered on top of the digital twin. And ultimately, we will be able to have a really accurate history of the site with all of its components, with recurring information that just updates constantly because these sites are, meant to live for 25, 35 years, and there's a lot that happens between them. So it's really important that we start keeping record And then also with the digital twin, we can go as far back as development. We can utilize the surveys and the hydrology assessment and see how those have evolved over time. So we're trying to put together the full circle, the life of the asset within a digital twin. So I'm really excited.
When you create this digital twin, I mean, you guys are probably using some industry leading tools like PVKs, maybe other design tools, some O&M software. Where, like, do you create your own, or do you collect your own raw data layer? Do you create that and then like maintain it on that internally, or do you connect all the data between the different SaaS tools? What are some such tools you're using besides your existing SCADA systems or other systems? It must get quite complicated. Like, how do you prioritize which data and what to collect, what to prioritize, what to organize? And I'm assuming right now you guys are focusing on more the live asset piece. And like, what are your future plans as you evolve this more data-centric management of these power plants?
So maybe I can take that question. There are quite a few softwares that the team is using cross functionally. From the beginning of the life cycle, we tend to use what we would consider rapid design tools, or yeah, I mean that's really the term that is considered. You
What are
mentioned
some examples of those
yeah,
rapid design?
PVKs, Plan Predict, Rated Power, which I believe they changed their name to something different. Obviously AutoCAD, but there are a lot of tools and cross functional platforms that we can use to
Yeah.
combine, just engineering software and those. But then
Yeah.
there's a leverage of GIS platforms that we have with a fairly robust GIS team that we have internally. So, from the very beginning, we start putting all of that data into a GIS platform. Eventually, as Jimena said, we're trying to collect all of this data. There are so many different sources, from O&M logs to equipment, supply, rosters, all of these things into one place. So it's that unification that is the ultimate vision, as Jimena said, a digital twin that has all of this metadata and attributes tied to it. So the platform that we're probably navigating toward, and maybe I don't want to spill too much of what our secret sauce is. At the same time, I think this is what the industry needs, is to help standardize, is OneMap, right? OneMap is a fairly large software platform that is used not just in the solar industry, but in a lot of other different types of construction and other energy and so many other platforms. So leveraging that to help combine all of these relevant items is where we are looking into, whether it's pulling drone information from layers that we collect, whether it's internally through a third party, or drawing and survey data that we're entering in. The second part, or the next phase of it, is tying all of these attributes to all of these different components and leveraging that information as we get into that operational phase.
And that can also take you. Oh, go ahead, Jimena, please.
No, I was just gonna add that, for example, I think Lightsource and maybe other companies that operate internationally, we face the challenge that, in Australia, they might have a provider. And then in the US, we have a different provider. And even in the US alone, we have different providers for different things. We have different O&Ms, we have different APCs. So we need to work to build our systems to be able to have inputs from all these different providers worldwide. So we need a way to have our data centralized and standardized for our business purposes, but we also need to be able to be agnostic to who provides the services, because we're not experts in every single platform. We're not software developers. We're not trying to beat people in their fields or be the best at everything, but we do need to be able to ingest all that information and consolidate it in a way that it informs the business as a whole, regardless of where the asset is being built or operated.
Yeah. And this makes a lot of sense as the industry is growing, and and everyone's operations are getting so much more complicated and sophisticated. And it's great that leaders of the industry are thinking about standardizing these approaches to data collection and management. I'm assuming you guys have probably a dozen plus different software tools that you use in your processes, and it must be quite a task to like prioritize which layer to do first, and then the next layer, and also scope wise, like okay, operating the real asset, but then maybe like focusing on the earlier stages of development as well. So when you think about like the North Star of your approach here, what do you think of like as being the ultimate goal of all this data activity, if you will?
Well, I think my North Star is always, why we do this, and that for me, it's provide clean, reliable, renewable power and that performs, right? Because you can't have a reliable system if you have an underperforming plant. So I think it all works together and, performance of the plant. We want these are essentially living, breathing things. If an inverter goes down, the plant goes down, performance goes down. So I think that's our North Star, just having good, reliable power on the grid and having good performing sites overall. And that comes with, having the right information and having the right tools and having the right data to diagnose the issues. And, it's all within the same realm.
Got it.
Yeah.
And
I was going to say, if I were to give my North Star in terms of what this means, there's an element around our industry that, and maybe it's certain feelings or how people see what solar or what renewables mean, is it's always lean, cheap, and in some cases even a race to the bottom, right?
yeah,
Our industry is very competitive amongst our peers and our other developers, and then also our contractors, all of our business partners, our suppliers, etc. There always seems to be this notion of, at least in the US market, a race to what is the cheapest form of delivery. And by leveraging data, by looking at what all of this data means, it is going to help make a competitive edge on how we become more efficient. And a lot of it means like how we spend our time to find more of these opportunities to deliver better assets. We deal with markets where solar may not be the most favored. So we have to use, data in those phases to identify better solutions. When it comes to operations, we've seen a lot of the most recent media coverage of the storms that have, decimated project sites. So how do we use data to help prepare those sites, for those types of incidents, whether it's hail, wind, or otherwise, and then how we make equipment selection based on that location. All of those, inputs of data we can use and become more, not just a better competitor in the market, to win more projects, but also, drive the market towards better resiliency than just, cutting costs.
And a big
I
one that supports that, I think it's predictive maintenance. And that's where we're
Mhm.
trying to get at. So for example, like, there's multiple inverter OEMs out there and they all have their thing, but
Yeah,
it's how you prepare for the events that are going to cause
right.
downtime. So you can get to a point where if you analyze the data, long enough and deep enough, you can understand that, for example, close to the summer in Texas, certain OEMs have fan failures. And if you don't have the right piece or the right fan within your spare parts, then you have a derated inverter for as long as it takes for the part to arrive. So these are the type of insights that we're driving in terms of, what caused the loss of production and how we can prevent it in the future so that we have extra amount of fans right before the summer and we mitigate that kind of lost production. So we're really trying to get to that point where we're trying to predict and be ready for those instances.
That makes a lot of sense. And another challenge must be that you guys are probably working with dozens of different EPC partners because you don't have the workforce to develop all your plans. I would assume. And then how easy is it to I don't want to use the word enforce, but encourage those EPC partners to think about data in the same way you guys are, and to input all the pieces of data that is necessary during the construction, post-construction. I don't know if you necessarily use their workforce for O&M function post go live. How do you approach that problem?
So I can certainly say that's probably one of the bigger challenges, and it's not to say that an EPC is going to be that challenge. We hire our EPC partners to deliver. That is their
Sure.
bread and butter. That's what they do. Our business is to bring these projects forward. So it becomes very hard for us to navigate the line of being too prescriptive, but also asking for the information that we want. So to some of the points that Jimena made earlier around being agnostic, it doesn't just, evolve to a global problem of how we navigate different markets. It also becomes a smaller problem here when it comes to navigating different contractors. So it really, we have to look in and see how we can ask for all of the same information in a simple way that we can extract all of it and put it into our tools and systems. Obviously, the objective would be for all of them to use that same platform. And I think we can get there at some point. But with what we have now, that is the direction that we're moving toward.
Right. Kind of bringing that standardization to the industry, where that point you made earlier, Armando, about like not making it a race to the bottom, making it a quality product, but built, not maybe with a little bit more extra cost, but will pay off in the maintenance years for the decades to come.
Yeah. And I
Jimena, I
think like,
remember
oh,
in one of our previous conversations, you talked a little bit about how you guys are really leveraging more and more of drones and robots in terms of EPC quality and the deliverables. Like, can you talk a little bit about the trends you're seeing in terms of new technologies to kind of monitor and also assess the quality of the jobs done at the construction sites, and how that is becoming evolving?
yeah. So there's some great players out there, Raptor Maps, Terabase. There's a lot of good technologies, and we're starting to use it. One, in terms of construction monitoring progress, and that is, sending out a drone and telling us how many piles have been installed and how that reflects it in the percentage of the site built. And then on the O&M side, we're more used to IR scans, which gives us the thermal signature that can identify whether a module is online, offline, or if it has a cell level defect. With that said, where we're going is we're actually working on a pilot right now with autonomous drones. So what we're doing is we're putting drones on the site that are able to do repeatable missions as well as be called on demand. So this means, we can do a monthly infrared survey that will tell us all the strings of line, and that can be constantly communicated to the O&M, but we can also deploy the drone in the event of a hail, in the event of, or even just to check whether the site is stowed right, before a big storm. I always joke about, looking out the window and somebody's asking you, is the site stalled? And you look out the window and you say, yep, but these sites are like beyond our line of sight. So they're just getting bigger and bigger. And, humans, it's really hard to have that coverage. So we need to use drones. We need to use technology. And it's also a way to quickly digitalize and have a digital record of the site that feeds into the digital twin, like we said. So yeah, we're actively, trying to identify what the best technology is. We're working with the leading companies in the US to provide us these solutions. And I think a big part of this is also that our industry has grown so fast that everybody's trying to do something new. And when everybody's trying to do something new, it's really hard to find the experts in their field. So yeah.
Seems like nowadays, like a lot of this data activities are driven by compliance and reporting requirements. How important is it to define those in the right way? And I think we also talked about orange button. What are some levers that industry leaders can play with or bring forth to create the standardization that you would like to see in the industry? How do you think about that?
Well, I think a big one is GADS reporting. This is a requirement that actually started earlier this year. It was mandatory for any power plant north of 100 megawatts to report in a certain way. And it's a very specific way that dictates, what the plant ID should be, how to input the megawatts, that the data needs to be in 5 minutes, that we need to define certain issue a certain way. So I think some of these regulatory requirements are going to drive how we need to maintain our data to be able to fulfill this. But it's really hard to get everybody to standardize across. Like I said, everybody's using their own systems. One
Yeah.
EPC might use Procore, the other one might have their own internal software. So it's really hard to maintain that currently. And like you mentioned, initiatives like Orange Button, they're really trying to work to see what is the best way to have a single solar standardized data set across, every single owner, asset, company.
Yeah. Data problems, well, plenty of them. It seems like on in your field, and we talked about how a lot of data-oriented young professionals are going to, the big tech sector, but more and more the big tech is becoming energy dependent. So perhaps we can create those challenges in our industry to have them tackle the data challenges that our industry is facing. So on that, Armando, do you have any thoughts to attract those types of young guns and professionals and to
I mean, it's I feel like it's one of the areas where our industry isn't necessarily calling to, the data scientists and the computer engineers that we tend to see going to big tech, right? And
yeah.
part of it is because energy isn't always the most glamorous or
Yet
yeah,
yet
yeah,
It
right?
isn't. It isn't.
yet. But this conversation reminds me of something Bill Gates used to say when I was first starting my career 30 years ago in the tech sector. He was back in the mid 90s complaining that the brightest minds were going to Wall Street instead of going to tech. That changed about 15 years later. About 15 years ago, they started going into Silicon Valley instead of, Manhattan and big, Wall Street guys. A lot of bright guys started coming to Silicon Valley ecosystem. But I think the next phase of that hopefully could be our industry.
Yeah,
So yeah,
one of the big things to me is always as an engineer, one of the things that I value is seeing, what we're the product of what we're putting into the ground and the longevity to it. A lot of tech and I don't mean this to be in any way disparaging, but a lot of it tends to go up and go away fairly quickly, whether it's apps or some startups, right? With energy, it tends to be something that has longevity, as well as we're always going to need it. As time progresses, the need for energy continues to grow. It's not going away. It's one of the pillars of our our lifestyle, our industry, our future, and it really feeds to no matter what you go into, it's there. We need it, right? The lights are on in this room. The lights are on powering this recording. So it's really it really speaks to that. So when it comes to a call to attract that talent, there's that opportunity of all of the unknowns that haven't been really discovered yet or really explored. Because one of the things that really enlightens me about the ideas and innovations that Jimena, as an example, has brought forward is how we can leverage these new technologies and providers, which is still even very early on, to make value of of things, for our industry. The solar industry has been building projects the same for the past 15, 20 plus years. A module gets connected, goes to an inverter, reports data, how it's generating, and that's pretty much it, right? You've seen progress in inverters, modules, etc., tracking systems. But at the end of the day, all of that stuff stayed the same. We're still going through the same maintenance.
Except the sizes. The sizes of the sites have grown substantially. I'll say that because I had some mentors, like the biggest site they had built a couple of years ago was 10, 20 megawatts, and now we're hitting like 800 and above. So I'll just say that the size has definitely changed and the speed of growth
Yeah.
of our
And
industry.
and that's a good point, right? You're still seeing that massive amount of land, but it's obviously a lot more dense when it comes to the energy per acre. And I think that's where we've seen a big part of that transition. But to the point of where what value individuals can bring and this new talent, coming out of school can bring is looking at how they can make our industry more efficient, right? We're looking at putting in new solar parks, all across the U.S. and globally. But we're very quickly going to see that we're going to repower a lot of these older parks to make them even better and bigger because the need for energy continues to grow, right? We're quote unquote running out of land, or really not, but we can make the land that we've already used even more efficient. Finding ways to make that cost effective is really in the data. And all of that starts from being smart about how we maintain it, looking at what attributes we have with certain equipment and how long it lasts, to not just speak back to any specific manufacturer and say this is a great product, or hey, I really like to see some improvements as we move forward into the next iteration and next version. So it really helps all across the board our industry move forward.
What a great call out to data scientists who want to enter our industry. Thank you for that, for those last words, Armando. Any other thoughts that you want to add, guys, as we come to the end of this conversation?
I'll just add that I think the biggest problem right now is that data comes in chunks in different stages of the asset, but it's still one asset, right?
Yeah.
And ultimately, where I think we should get to is we should have a single record from when the site was, first designed in the development process. And then that same record should be transferred over, and hold all the EPC data. And that means what failed, what quality was flagged, all those details that kind of get lost within all the PDFs and all the Excels and all the punch lists and all the work that's been done, that's not really captured. And then it is also where scopes start and end. You have a different scope from who designs the plan, and then they give you all the information, and then it's on to the next, and then the next grabs all the documents, does their thing, finishes, and then it's up to the next. But it's still a single asset. So where I would like to see us grow is it just should be one thing. We should be able to tell what the development engineer was thinking. We should hold all the information of who built the plant. We should have, all the operational data, which is we're getting pretty savvy around it and how do we historize it. And then, we get to a place where I know Armando is really passionate about, and it's the levelized cost of energy. And at the end of the day did we make the right decision initially, and did that pay off in the operational side of it? Or did we make the wrong decision initially, and our projects are not as profitable? So I think data should be just encompass the whole life of the asset, and we should use it as best as we can so that we can understand how to build better plants, how to make better decisions, how to not just buy the cheapest equipment, but not just the initial cheapest equipment at like face value, but to really buy the optimal equipment that will sustain the asset in the best possible way. So I really hope we get there because we are tech, and speaking to everybody who wants to join, we are tech, we're using AI, we're using SCADA systems, there's controls, there's data like wherever you look at it. I'm working remote and I can access a plant in Texas, you know? That's fun. And it is fun to be able to watch it live and to drive insights and to have information even being so far away. So we are tech. And I think where we're going is where it gets the most fun. There's a lot of like Armando said, energy is the pinnacle of our society. And our energy consumption is only growing faster than we can all catch up. And we need the AI to support this. We need the computer scientists to help us, you know, gather all, build the code so that we can be program agnostic. So what I'm trying to say is we are tech and we're not just a commodity. We are like, this industry is a necessity. So I think it's pretty cool to be able to have all those insights and see everywhere I look in the solar industry, people are driving innovation, people are driving insights. I think everybody's working with data to a fault because we can't all agree how to unify that data, but we're all data driven. And I think I'm just really excited to be a part of this group and be able to be part of this transition where everything's growing so fast. We need energy and we need data to help us, data and technology to kind of help us get there. Because there also is not going to be enough people to build our sites, and there's not going to be enough people to be monitoring such large assets. So we need data, we need technology, and really we need people who care about what they're doing and who want to put, you know, passion and effort into having good, reliable power plants to power our grid.
Well, thanks for that summary, Jimena and Armando. What a great in-depth conversation about the challenges of data in this very rapidly growing segment of the energy world. At this point, solar is well into the mid-single-digit percentages of our energy infrastructure worldwide, and it is growing, as we talked about, very rapidly, probably 20 to 30% compounded annual growth rate worldwide. And with that comes all this data challenges for the largest and also small and medium-sized developers. And this conversation has been a eye-opener for me in terms of the vastness of optimization and improvements that we can bring to the industry. And I hope that will bring more data scientists and tech people to help these issues we're facing as an industry. Thanks a lot, guys. Thank you, Armando, Jimena, for this conversation. Yeah, with that, I will end this solar conversation with more to continue. Thank you.
Thank you.
Thanks so much.